Good morning, students. Today we are going to discuss about measurement of basic quantities. Under that, we are going to study measurement of length. Before going into that, we all know that there are 7 fundamental quantities. What are they? Length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Out of these 7 fundamental quantities, there are 3 basic fundamental quantities. There are length, mass and time. This length, mass and time are called basic fundamental quantities. These basic quantities. Now we will see about measurement of length. What is length? The distance between 2 points. The distance between 2 points is called length, and the unit is meter. The unit is meter, and the symbol is yeah. Now, if I want to measure a cloth, how I can measure with the help of meter scale? Like that. If I want to measure a rope, I can measure it by using tape. Suppose, if I want to measure a larger object which is at longer distance, like sun, earth, moon, galaxy, etc. So, to measure a larger object which is at longer distance, how I can measure? There are 3 units. What are they? Astronomical units, light year and parsec. One astronomical unit is equal to 1.496 into 10 power 11 meter. One light year is equal to 9.467 into 10 power 15 meter. One parsec is equal to 3.26 light year. Suppose, if I want to measure a smaller object which is at smaller distance, like protons, atoms, molecules, neutrons, bacteria, etc. For that, there are 3 practical units. One is angstrom unit. Second one is Fermi, the third one is nanometer. 1 angstrom unit is equal to 10 power minus 10 meter. Like that, 1 Fermi is equal to 10 power minus 15 meter. 1 nanometer is equal to 10 power minus 9 meter. So, 1 angstrom is equal to 10 power minus 10 meter, 1 Fermi is equal to 10 power minus 15 meter, and 1 nanometer is equal to 10 power minus 9 meter. These 3 units are used to measure larger objects which is at longer distance. So, we can call it as macrocosm. Like that, these 3 units is used to measure smaller objects. For that, we can call it as microcosm. It is clear. Now we will go for methods. There are 2 methods. One is direct method, the other one is indirect method. In direct method, distance ranging from 10 power minus 5 meter, to 10 power 2 meter. Distance ranging from 10 power minus 5 meter to 10 power 2 meter, we can use direct method. For meter scale, again, the range is from 10 power minus 3 to 1 meter. For vernier caliper, up to 10 power minus 4 meter, and for screw gauge it is up to 10 power minus 5 meter. These are the examples for direct method. Now, if I want to measure a longer distance, then I can use indirect method. One is triangulation method, second one is parallax method, the third one is radar method. In 9th standard, you learned about vernier calipers, and last year you learned about screw gauge. Once the school reopens in person, I will explain about vernier caliper and screw gauge during class hours as well as during practical hours. Understood? Now, today we will discuss about screw gauge. Now, I want to measure the diameter of a lead shot. Now, this is a lead shot, and I want to find out the diameter of this lead shot. How I can find it out? With the help of screw gauge, I can find out the diameter of this lead shot. Similarly, if I want to find out the diameter of a thin wire, I want to find out the diameter of a thin wire, or I want to find out the thickness of a thin glass plate. Thickness of thin glass plate. For all these things, we can use screw gauge. Okay. Now, this screw gauge has having two principles. One is linear motion. The other one is circular motion. Linear motion means if I rotate the screw moves linearly towards the stud. That is called as linear motion. Now I am rotating the screw, that is called as circular motion. Then there are three types of errors, zero errors. That is, one is nil, the other one is positive error, the third one is negative error. Suppose if the zero of the pitch scale and zero of the head scale coincides, then I can call it as error is nil. If the zero of the head scale is below the reference line, then I can call it as zero error is positive. If the zero of the head scale is above the reference line, then I can call that error as zero error as negative. Let us see. Now this one is pitch scale. This is reference line. So, pitch scale. This one is head scale. And this one is reference line. Now in this diagram you can see the zero of the head scale coincides with zero of the pitch scale, then I can call it as zero error is nil. Similarly, now in this diagram, the zero of the head scale is below the reference line. The zero of the head scale is below the reference line. I can call that zero error is positive. So that zero error is positive and zero correction will be negative. Zero correction will be negative. Now, in this, the zero of the head scale is above the reference line, the 0 of the scale is above the reference line, then I can call 0 error is negative. So 0 error is negative and 0 correction is positive. How to calculate total reading? Total reading is equal to pitch scale reading plus head scale coincidence into least count. Least count for screw gauge is 0.01 millimeter. Screw gauge, most commonly known as micrometer screw gauge. It is an instrument used widely for precise measurement of small objects such as wire. The word screw gauge is used because this device most commonly used to measure diameter of the wire. The word micrometer represents the principle on which the device works, which is called principle of micrometer screw. Principle of micrometer screw. A screw gauge is constructed in such a way it incorporates the principle of micrometer screw. In addition to screw and nut, a U-shaped frame is attached at one end of the nut. This nut, also called it as sleeve, has readings on it. These readings measure the linear distance moved by the screw. This scale is called linear scale or pitch scale. The other end of the U-shaped frame has a metal projection called a stud. When the screw is moved forward, the stud and the screw together hold the object firmly. The screw is attached to a milk head with sloping edge which rotates over the sleeve. The sloping edge has a scale which is called as circular or head scale. The pitch of the screw gauge is the linear distance moved by the screw divided by number of rotations of the screw. To find out the pitch, the circular scale is rotated to bring the 0 mark on the reference line. The linear scale or the pitch scale reading is noted down. We count the number of divisions on the linear scale completely uncovered by the cap. Here is 2.0 millimeter. Now we rotate the screw 5 times. When the 0 mark of the circular scale again arrives at the reference line, one rotation is said to be completed. We again note down the linear scale readings after 5 rotations. It is 7.0 millimeter. We get the linear distance moved as 7.0 millimeter minus 2.0 millimeter, which is 5 millimeter. Thus, pitch can be calculated as 5 millimeter divided by 5, which is 1 millimeter. The pitch of the screw is 1 millimeter or 0.1 centimeter. Therefore, the distance moved by the screw in one complete rotation of the circular cap is 1 millimeter. Now, the circular cap is divided into 100 divisions. Then, if the cap is moved through one division, then the distance moved is 1 by 100 of the pitch, which is the least count of the screw gauge. Pitch divided by number of division on the circular scale is equal to 1 by 100 millimeter, which is 0.01 millimeter or 0.01 centimeter, which is 10 power minus 5 meter, which is 10 into 10 power minus 6 meter, that is equal to 10 into micrometer. In addition, as a least count of screw gauge is in the order of micrometer, it is called as micrometer screw gauge. Zero error, backlash error. Sometimes in the given screw gauge, when the screw completely touches the fifth stud, the zero of the circular scale does not coincides with the reference line. Then the instrument is said to contain the zero error. Calculating zero error. In order to find out the amount of zero error, the device contains the position of zero at the circular or head scale with respect to reference line is absorbed. When the zero of the circular scale is below the reference line of the linear scale, then the zero error is positive error and the zero correction is negative. Here, in this case, 11th division of the circular scale coincides with the reference line. Thus, the extra length it measures is 11 into 0.001 centimeter. The correction is minus 11 into 0.001 centimeter. Similarly, when the zero of the circular scale is above the reference line of the linear scale, then the zero error is negative error and the zero correction is positive. Here, in this case, the 90th division of the circular scale coincides with the reference line. Therefore, zero error is 10 into 0.001 centimeter and the zero correction is plus 10 into 0.001 centimeter. Now, after determining the least count, pitch and zero error of the screw gauge, we are now ready to find out the length of any object. Let us say to find out the diameter of a wire. We place the wire between the fixed stud and the screw by slowly moving the screw with the help of the ratchet until the wire is gently held. The diameter of the wire is nothing but the distance the screw moved from portion A and B. This distance is equal to the length of the portion X plus the length of the portion Y. Here Y is equal to 31 division. Mathematically, for one complete rotation of the screw, the reading is 1 millimeter. 100 division is equal to 1 millimeter. Therefore, 31 division is equal to 31 into 1 millimeter by 100. Therefore, portion Y is equal to 0.31 millimeter. Total length is equal to portion X plus portion Y, which is 1 millimeter plus 0.31 millimeter, which is 1.31 millimeter or 0.131 centimeter. Now, portion X is equal to linear scale reading or pitch scale reading. Portion Y is equal to 31 into 1 millimeter by 100. 31 is number of divisions of the circular scale cross the reference line of the linear scale. 1 millimeter by 100 is the least count of the screw gauge. Therefore, total reading is equal to linear scale reading plus n into least count, or another way, total reading is equal to pitch scale reading plus head scale coincidence into least count. Now, we are going to discuss about vernier caliper. This vernier caliper instrument is used to find out the diameter of a hole. Then, it is used to find out the depth of a hole. For example, if I take this pen cover, I want to find out the diameter of a hole, I can use this vernier caliper. Similarly, if I want to find out the depth of this cap, I can use vernier caliper. Before going to take measurement, first of all, you must check whether the instrument is having error or not. That is nothing but zero error. There are three types of zero error. One is zero error nil, then zero error positive, then zero error negative. Suppose if the zero of the vernier scale, this is vernier scale and this one is a main scale. If the zero of the vernier scale, if the zero of the vernier scale coincides with the zero of the main scale, then I can call that zero error is nil. Next, if zero of the main scale is just before the zero of the vernier scale, if the zero of the main scale is just before the zero of the vernier scale, then I can call it as zero error is positive. So zero error is positive and zero correction will be negative. Suppose if vernier scale, that is if zero of the vernier scale is just before the main scale, if the zero of the vernier scale is just before the main scale, then zero error is negative and zero correction is positive. Here if I tell, here zero error is nil as well as zero correction is also nil. For vernier caliper, the least count is 0.1 millimeter, and to find out the total reading, that is a formula. Total reading is equal to main scale reading plus vernier scale coincidence into least count. Vernier caliper is an instrument which is most commonly used in physics laboratory to measure length of small objects accurately, which could not have been possible in meter scale. The word calipers in any instrument, two jaws used to determine the diameter of an object. Vernier caliper was invented by French mathematician Pierre Vernier in 1631, and thus the name vernier caliper. It consists of a long rectangular metal scale with fixed jaw at one end. It is graduated in inches at the upper end and centimeters at the lower end, which is called main scale reading. There is a movable rectangular metal scale which is graduated a special relation to that of main scale, which is called vernier scale. It slides over a long metal scale. It has a jaw similar to the main scale. These jaws together hold the object firmly and measuring its length, which is not possible in meter scale. These jaws are called external or lower jaws, which is generally used to measure the diameter of the sphere or cylinder. These jaws are extended to other side called internal or upper jaws and generally used to measure the internal diameter of hollow cylinder. There is also a metal scale attached at the back of the vernier caliper, which is used to measure the internal depth of the cylinder. This instrument works on the simple principle known as the Vernier principle. According to the principle, the given length x is divided into n minus 1 and n smaller divisions. Each division of different lengths which represent by 2 scale as shown. Let us say the distance of 9 millimeter is divided into 9 divisions on one side and 10 divisions on the other side. Then 10 divisions of scale B is equal to 9 divisions of scale A. 10 into B is equal to 9 into A. B is equal to 9 by 10 A. B is equal to 0.9 divisions on scale A. Here, the upper scale A is called main scale and the lower scale B is called Vernier scale. One Vernier scale division is equal to 0.9 main scale division. As the length of the main scale division is equal to 1 millimeter, then one Vernier scale division is equal to 0.9 millimeter. Therefore, each Vernier scale division is shorter than main scale division by 1 by 10th of main scale division or 0.1 millimeter. Thus, we can clearly see the first mark of Vernier scale short by 1 by 10th of main scale division. Thus, 10th mark of Vernier scale short by 10 by 10th of main scale division. Therefore, the 10th division of Vernier scale coincides with 9th division of main scale. Now, let us try to move the Vernier scale very slowly left to right. Now, 0 of the Vernier scale is moved to right marginally and the first mark of Vernier scale still does not coincide with the first mark of main scale. In this phase, we can't measure displacement. Now, we try to move 0. The first mark of Vernier scale coincide with the first mark of main scale. Now, we can finally say that the displacement of 0 Vernier scale, 0 main scale is 0.1 millimeter because first mark 0.1 millimeter shorter of 1 main scale division as explained before. Now, we move even more further such that second mark of Vernier scale coincides with the second mark of main scale division. The distance between two zeros is 0.2 millimeter because the second Vernier scale division is 0.2 millimeter shorter than second main scale division. Similarly, when the 10th mark of Vernier scale division coincides with the 10th main scale division, the distance between them is 1 millimeter. Therefore, the distance in the order of 0.1, 0.2, 0.3 up to 1 mm or 0.1, 2 into 0.1, up to 10 into 0.1 mm. Thus, we can say that the least distance that can be measured accurately by the Vernier caliper is also known as least count or Vernier constant, that is equal to 0.1 millimeter. The distance is nothing but difference between one main scale division and one Vernier scale division. When both zeros coincide, thus least count is equal to 1 main scale division minus 1 Vernier scale division. In Vernier calipers, n division of Vernier scale is equal to n minus 1 division of main scale division. Therefore, 1 Vernier scale division is equal to n minus 1 divided by n main scale division. Substitute the values of 1 Vernier scale division in the above equation. Least count is equal to 1 main scale division minus n minus 1 by n main scale division. Simplifying the equation, we get least count is equal to 1 by n main scale division, which is length of one main scale division by number of divisions on vernier scale. After obtaining the least count of the vernier, let us proceed to calculate the length of any given object. Now, let us say a very small object of length x is placed between jaws. In order to find the length of the object, we need to calculate the distance between the two zeros. This can be obtained by subtracting the length from 0 to coincidence of MSD and VSD and length from 0 of vernier scale coincidence of vernier scale. Here 7 main scale division minus 4 vernier scale division. This can be written as 3 main scale division plus 4 main scale division minus 4 vernier scale division, which is 3 main scale division plus 4 into main scale division minus vernier scale division. 3 main scale division is equal to reading that can be measured by main scale. Therefore, main scale reading is equal to 3 millimeter, as one division of main scale is 1 millimeter. Now, this portion is extra portion between the 3 MSD and 0 of vernier scale, which can be measured by vernier scale and is nothing but 4 into main scale division minus vernier scale division. 4 is vernier coincidence. Main scale division minus vernier scale division is the least count or the vernier constant, which has calculated before. It is 0.1 millimeter. 4 into 0.1 millimeter is equal to 0.4 millimeter. Thus, the length is 3 plus 0.4 is equal to 3.4 millimeter. Thus, the formula for calculating total reading is given by MSR plus VC into least count. Zero error. The 0 of vernier scale do not coincide with 0 of the main scale. It is either right or left of it. So, let us say in a given instrument, if the 0 of the vernier scale is to the right of the 0 of the main scale, in this case, the particular division vernier scale coincides with the division of the main scale. Now, this can be understood as a vernier caliper is already measuring certain length as its object is placed in between the jaws, even though no object is being held. Now, the extra distance is extra reading. The given vernier caliper is measuring an extra length than actual length when an actual object is to be measured. Thus, our interest to measure extra length. Now, in this device, for example, an interesting point to observe that the 5th division of vernier scale is coinciding the division on the main scale when it is normally at 0.5 millimeter to the left or right of any division. Thus, we can say that this extra length is wrongly measured by this vernier caliper 0.5 millimeter. Therefore, we reduce this length 0.5 millimeter from the observed readings to obtain the actual reading. This type of error in which the 0 is to the right of the 0 of the main scale is called as positive 0 error, and the correction we made is 0 correction. In this case, the negative 0 correction. This reading can also be simplified by using the formula total reading is equal to main scale reading plus vernier coincidence into least count. Here, main scale reading is equal to 0, least count is equal to 0.1 millimeter, vernier coincidence equal to 5. Therefore, 0 error equal to 0 plus 0.1 into 5, that is 0.5 millimeter. Thus, zero correction is equal to minus 0.5 millimeter. Similarly, when the zero of the vernier scale is to left of zero of main scale, it actually measures less than the actual length. Now, let us say, for example, in this instrument, the zero of the vernier scale is to the right of the zero of the main scale, and the sixth division of vernier scale coincides with the division of the main scale. But in normal devices which are free from zero, the sixth division is actually at 0.4 millimeter at main scale division. Thus, we can conclude that this particular device measures a less distance of 0.4 millimeter. Thus, in order to obtain actual reading, we need to add this to observed reading. This type of zero error is called negative zero error, and correction is positive. Thus, total reading is equal to main scale reading plus vernier coincidence into least count. Here, main scale reading equal to minus 1 millimeter, least count is equal to 0.1 millimeter, vernier coincidence is equal to 6. Therefore, error is equal to minus 0.4 millimeter and the correction is plus 0.4 millimeter.